Hello everyone. So within a minute we'll start the session. Good afternoon everyone, and today is the first session for Docker and containers in whole. So let me start by introducing ourselves and what we are. As you can see from our website, we are Right Education, and our motto is to reach each and every person or student in like from all over the India and even from the world, so that we can provide them with the free education, or we can say the right education. Now there are many myths and there are many misconceptions in the society regarding many technologies. So we try to solve that and come up with a bright solution for that. So you can be updated by following the LinkedIn page, even Instagram page of Right Education, or you can come to this website, visit this website, and you can register for the upcoming courses. You can even contribute to our cause by joining to the Telegram channels, Slack channels, and just message them that I want to be an ambassador or I want to contribute to this society. Anybody from our team would ping you to for further communications. Uh, Now let's begin with the session. So I'm very excited because Docker is something which I'm very familiar with and I have worked so much upon it. If you want to know more about me, you can go to my LinkedIn page and you can know everything and all about me. And in this particular sessions or in this particular journey, we'll only look for the only focus on containers and particularly Docker in that. There are many container tools like Docker. There is Podman, there is Cryo, and there are many more like that. Marathon, if you know. So we'll just pick up the Docker, which was the initial one and the first one to capture the market very fastly. And the features that Docker provides is so much higher than any other container technology. And to even let's say if you are very familiar with other technologies, let's say machine learning or cloud, etc., then you can even go to my channel, visit it once. There are few videos on Docker and integration of Docker with machine learning and even deep learning. So you can go and watch it out so that you can get more idea on it, like how can we use Docker in machine learning also. If time permits in this session, at the end we'll also take few parts of integrating it with different technologies or tools. But for now we'll just focus on containers and Docker. So let's start. um, First of all, I would like to first distinguish between a particular thing, or want to tell that for today only the session are at Sunday, I guess Sunday, and from 5 to 6:30 p.m. The 5 to 6:30 p.m. would be regularly, but the sessions would be from for 2 days, which would be Thursday and Friday. As I guess there would like there are other sessions going on for Linux, and in future there might be more coming up. Um, and I personally believe that taking digital notes is not a good idea. Okay, so if you don't have a pen or a notebook with you, you can take some time, bring it, and have a written note, because I would be using this the same kind of interaction here as of now, and in future classes I would also make a doc in which all the screenshots of the commands would be there. So for today's session, you might not need there might be few commands to be run, but in future we will have more. So for that case, I'll create a different a Word document, and I'll share it via the drive link, as I guess it's done in the Linux classes, right? Fine. So first of all, let's understand what were the problems faced by the industry, or let's say in general the IT industry, when like few decades back, let's say about when it was 2000, or even till 2015 16. Okay. So in IT world, if broadly speaking, let's say if the company is in software development and providing software consultancies and developing softwares, so there are some phases in the process to make a complete product, end-to-end product. So what are the steps that this companies follow? So first of all, let's say if they have any clients, or let's say that they are a software company in itself, so they will have a research team, an R&D team. Okay, yeah, here. So what they will tell to the technical team, let's say there's a tech team. So they will say that these are the problems, or client will come and say this is our use case that we are looking like this is the use case which we want to solve. And what would be this use case? It can be a problem, a general problem of a particular company. It can also be a project for a client, and it can also be an independent project. Let's say famous example is Facebook. Now everybody would have watched the movie about Facebook, right? About Mark Zuckerberg. So in that also he gets to know about the problems, and he started developing Facebook with help of some of his friends and other colleagues. So this is how it comes. First of all, there would be a use case coming either from clients or R&D team. Once we have the use case ready, the document is submitted to our tech team. Another, actually, this would be our developers team. Developers team. So what happens in here in the part where developer sits? So they have let's name tech team 1, tech team 2. So in here developers would be called, and they would be briefed, and they would be given each and every detail about the project, about the um, project or general idea they are going to solve, about the use case in general. So what they will sit and decide, they will decide about the technology stack, what all stuff they might be needing in terms of technology. Let's say they might need this particular programming language for one thing. And in industry, remember one thing: you can't rely on one language or a tool. You need to have a knowledge of group of languages, and you need to have knowledge about group of other technologies to finally make a single product out of it. Like it's very logical, right? But we haven't thought about this anywhere. Let's say if you right now look at any product, if you say about LinkedIn, LinkedIn is an web app and a mobile app, right? So LinkedIn, if you see, the front end would be as of a web app or a mobile app, as I told you. So if it would be web, so they will have a totally different technology stack, and if they have mobile app, they have totally different technological stack. But right now, due to and due to a tool called Flutter and others like that, now you can create both using a single platform. But that's another thing. But you need to know, still you need to know the knowledge of web and mobile stack. And even at the back end, this was just for as the front end or creating an application. At the back end, there are many things which needs to be taken care of. So you cannot rely on one language, or you cannot rely on a particular technology that you learn. So they would decide that, okay, for this let's say for making databases or for creating APIs, we will use Python. For creating front end, we might use this. For creating the uh, there's also an layer between them, which is called the underlying intermediate layer. Like there are many things involved. They might even use Terraform, or yeah, let's say to automate the task, they might use Ansible. Okay, so they will list all different kinds of technology, and they will get ready with a plan. Okay, so let me clear the screen, right? Yeah. So once the developer team is ready, like ready with all the things, all the requirements, all the technology and detailed report, they start like this one more step, which is called the approval step. Everything is reviewed by the customers or clients or the R&D team, or whether or not you require exact this kind of thing or not. Once it's approved, they would move to another step of developing stage. Now note everything right now, because this is important. This would create a base of a very interesting thing, that why uh, we need containers. And actually Docker, let's say why we need Docker or containers, why we need this technology right now. So once it is in a developing stage, there will be, excuse me, uh, yeah, so there would be many developers or team of developers. Let's say there would be team 1, team 2, there will be so many teams, and each team would be assigned a different task to build or different functionality to build. Because even if you see Facebook right now, Facebook, so they have Instagram, they have WhatsApp, they have right now we can say that metaverse is the father father. And now, so the whatsoever it is, so they have each team handling one thing, and even inside this they will have each team to manage a particular function. Let's say post is a function, even to have like or subscribe on YouTube, etc. They have a dedicated team working behind, because behind the scene there are so many things to be guided and to be monitored. Okay, so all this team would work together, would build a particular part of a project, and then integrate it. Once it is done, it is sent for a testing purpose or testing team. Here everything would be tested, like from UI to user experience. Even they will test the functionality. Even they would they will have a benchmark, and they would even force the app to do security test. Even they will go beyond the capabilities also, like they will also consider the RAM and like CPU consumptions and everything. And once the testing team says okay, the app is ready to be deployed, now deployments to be given to clients for use, they will again send this to a particular team called operations team. Here operations team, the main task for the operations team is to deploy it perfectly. Now by deploying I mean, what we mean by deploying. So once you have code, let's say once you have code, once everything is set up, everything is coded, and you have the app also ready with you, you still need to publish it, right? You still need to give a user interface where the clients can come and connect. So it is done when the operations team actually create a server, and they put their code in it, and they start running that server. It can be a web server. Even in mobile phones, you need to deploy it in different containers, and these containers work together, and you get a full app running. Okay, so this is the whole process of a short explanation of how a project is carried out in the IT industry. Let's understand from this slide. As I told you, the main cycle starts when the developer starts coding until it's deployed. Now, in theory, it would look very, small. Right now, if you can see, okay, so Shubham, you are telling that there would be 3 to 4 stages. Developing stage where developers code the thing, then there is a testing team, and then there is an operations team. But remember, this process is very very tedious and very long. It takes around in the decade which we are talking about, it used to take so much of time. Why? As I told you, there are different teams. Okay, so each team after, when they sit to integrate, they have to there's something called knowledge transfer, KT. So they need to share each and everything about that particular module, or how it works, or how the APIs are called. Okay, so they need to give each and every detail, and then it's integrated into one software. So that takes too much of time. Okay, then the testing part also takes a lot of time, and finally deployment is another crucial task to be handled all together. So now let's come to the problems which are there in this system, and why containers were introduced. So what would happen, as I mentioned earlier, there would be different teams, right? So let's say this is team 1, and this is a team 2 handling different tasks. Let's say it's just for example, it's handling posts. Let's take the example of Instagram, because I guess everybody would be using Instagram a lot. So let's say one team is handling post, and another team is handling, let's say, profile. Okay. Yeah, I want to also mention one thing, that right now I am not looking to the chat, the live chat going on. I'll address live chat at the end of the session to see the doubts and solve your doubts. I would only take the technological doubts related to the sessions from the Q&A. If you have any managerial queries, then put it in your WhatsApp groups, or I guess Slack is active, so you can put it in management queries there, and somebody from our team will help you resolve these queries. And yeah, so that's what about the query session. It would be there, it would be at the last, don't worry about it. Right now just focus on the discussions and the learnings, and keep taking notes. Yeah. These were the two teams. Now let's say team one is developing its code using Python, and Python. Let's say there are so many versions. So let's say it's using version 3. then it might even use a particular language, let's say Go language of a particular, a very old version, name it anything, let's say version 0.2. Then they are using MongoDB of a particular MongoDB of a particular version, let's say version 1.12, etc. They would have many technologies different and their versions. And similarly, team 2 will also have different technology stack. Some would be same, but most of them would be different, right? Now what happens, let's say team 1 has finished the post part, they are ready with the post part, and they need to now integrate both of them. Okay, but before that they are individually tested, like whether or not post is working fine or not, or profile is working fine or not. Okay, so testing team. Now, what testing team needs to do? They again have to create the same environment. They need to create the same this environment here. They need to have same Python 3 version, same Go language, same MongoDB, or whatsoever technology they are using for both the teams. It's not for one team. It's for both the team. And in industry, as I told you, there are multiple teams working for different aspects of a particular software. So in testing also it requires so much time to create this environment. And at the time which we are talking about is long back. So at that time, either you need to have a physical system, like right now you are sitting in front of a laptop or a mobile phone, so you must have a physical system or PC. Or if you have a PC, then you must have a technology called VM, virtual machines. If you are enrolled with the Red Hat, sorry, not Red Hat, for the CentOS course, then you might know that what virtual machines are. Right now you might be working with CentOS VM, right? So you might have VMs in that. Okay, so when you would have been setting the VMs up, you might have seen that you need at least 30 minutes, right, for CentOS, if it is a GUI program. And if it is an CLI program, you even might need 20 minutes to set up. It actually depends on the bulkiness of the OS. Bulkiness, actually, it's not a kind of technical term, but it's referred to as the system is having so much softwares and so much inbuilt programs. That's why it is bulky, and that's why it needs so much time to come up. Okay. So let's say for testing team, for testing just a small part of post, they need to set up a VM of, let's say, it would take 30 minutes to 45 minutes in that case. So for 30 to 45 minutes, the team is ideally sitting. They are just ideally sitting, or for that time they cannot be productive, right? As in the promo video of this course, you might have seen an example given by me that right now the VM is starting up. It might take even an hour, so I'll go for a coffee break, and let's say uh, another team has sent their final program to test, so it even might take longer, so I'll postpone the work after 2 days, right? I In the promo video we have seen video, something illustration of that. So this is the problem actually. If you calculate this time, let's say 45 minutes in general for VMs for a team. So just calculate, just do the math that how much it would take if the team is, let's say there are 10 teams. It would be 450 hours. of ideal, the developers or the testing teams cannot do anything. Yeah, even this problem is with developers also. If you have a question that do developers also face this issue, yes, because they need to also set up a different environment, right? See, developers, again, take an example of Facebook. Facebook have so many developers, so Facebook might even assign few developers to initially for Facebook. Then when they acquired WhatsApp, they even send some of them to WhatsApp, right? So developers also don't have a fixed environment. They also need to change their environment according to their work. So they again set up a VM, okay, or they buy a whole new system, but that's not affordable, right? Buying a whole new system. Excuse me. Yeah, so that's also a problem with developers. So here we encounter, or here we came up with our first problem, which is it's time consuming. It was time consuming. And if you know, time is directly proportional to the revenue of the company. If you deliver your product, if you deliver your product late into the market, then you are actually affecting the revenue in negative way. Why? Because let's say, before you even introduce your product to market, someone else came in and he took all your competition, and he took all your customer base. So time is exactly proportional to revenue of the company. If you save time, so you are also generating more revenue. And if you are you are having, you are spending more time, then actually you are decreasing your revenue, and that's not good for the companies. Now let's come to our second issue, and that also you encountered in the same example, which was about the testing phase. Now how testing phase actually, if you see, so there are few factors like isolation. There are few security parameters would be coming in here. One is isolation, then other one would be the, actually it would be the system hacks are possible, like isolation, and actually we can say that it's the security part. Security. Now how, let's say if you are having a single system, and that single system you are having 2 to 3 VMs, and this 2 to 3 VMs are running different code. Okay, and let's say one of this code is a bug code, or there's a vulnerability inside it. And there's an hacker who is very smart, comes to know about this vulnerability. So what it can do, it can actually compromise that whole part, but it won't just be the this part, because it's the connectivity is internal. They might even get access of this too also. So you must have a proper isolation to each and every functionality. So that's very important, and that's the second point, that we need security. Isolations, or let's say security, is must in a technology where you are integrating different things from different developers into a single thing, or a single system, or a hybrid system. Security is must. And the third issue would be of environment, creating environment. Let's say, for an example, this is me, and this is my friend, and this was a situation. Let's say it's a situation something of like COVID. So what would happen, we have a complete isolation. I would be in my home, my friend Jay would be in his home. So what would happen, I will start developing a particular part of the software. Let's say I'm developing the search bar, okay, So I set up my environment, I wrote my code, and I sent it to my friend who is also a developer in the same company, and we are in a same team. Now let's talk about same team. Okay, forget about different teams. We saw what happened in what was the case for different teams inside a team. So I would send this code to him. Now what again my friend need to do is I and even I need to tell him that I have used this version, I have used this much software, and this is how in this document I have written how to set up everything and connect everything. After that only he can start developing further. Okay, after, let's say I just wrote half the code of it. Now another half is needs to be written by this person. So he needs to then start first do this, first set up his system or his environment, and then start coding. So these were the few problems which were majorly faced by the industry, but it was kind of inevitable at that time because there was no such technology which can, you know, be super fast or can solve this issue. So then the introduction of container technology came into play. But at that time, many of the researchers and many, like after the Docker technology came, after the container technology came, many of them said or many of them approved that this was actually not a, uh, the kind of thing which Docker is doing. We also used to do it earlier, but we have never thought that okay, we can use this solution to solve a great problem in the IT industry. And after this whole Docker or the containers session of, I guess it would be around 10 plus hours, so 9 to 10 lectures. So after this series you would very comfortable with it, and you would also know that what actually internally Docker did. Okay. Fine. So I guess you all understood the idea or the problems which were in the IT world and how it is solved. Now let's move on to it. How it was solved. Yeah. So let's say if there's a now coming to our era, let's say there's an technology called container technology, which is very far better than VMs and even your own systems. Actually, this is called bare metal. The setup is called bare metal. So containers are best apart from VMs and PCs. But why and how they are better? So let's take a let's first take a quick look into what Docker is actually and what I'm talking about. Like you would tell that, hey Shubham, you are talking about this container technology and the use cases and the uses, but how it's actually visualized and how it is actually working. So let's move to a quick practical. For that, as you might have your virtual machines, or if not, then I'll tell the team to share the videos and the necessary things to set your virtual machines. And if you are the part of the Red Hat, oh sorry, for the CentOS, the Linux track by Raktim, then you might know what VMs are and how to set up. But if you have a MacBook which is powered by the latest M1 chipsets silicon, so you will face an issue of setting the Docker or the VM, not Docker, sorry, for the VM. So in that case, you might need to have this UTM. It's also an virtualization. It's also a hypervisor. I will also talk about hypervisors in very brief. If you are not familiar with that, then you can again go to my either go to my channel if you want, and I have explained about how you can set it up, like three best alternatives for Red Hat or any flavor of Red Hat. Actually, CentOS, Red Hat, Fedora, all three would be similar because they are you know stream like upstream and downstream projects respectively for Red Hat. So you would get the same flavor there. So once you set up UTM, then I'll right now I might not have, but I'll show you how to set, how to completely set this virtual machine. And if you have Windows, then I'll tell my team to send you the videos for setting up the virtual machine. Okay. So right now I'll move to the practical. Don't worry about the virtual machine setup. As I told you, either you might have it, or if you don't have it, then my the team would definitely help you. Okay. Yeah. I guess a few of you might be even very new to the virtualization also. What is virtualization and stuff? So let me just quickly explain what is virtualization. Or we okay, sorry, we say it virtual machines, VM. So this concept came when we need to have different environment in a single system. Okay. So let's say you have your own PC. Let's say you have your own laptop here. And in laptop, there's everything like a RAM, CPU, hard disk, and graphic cards. Everything is inside it. It's called hardware. You have hardware. So I'll again draw it here. So you have this hardware level. Okay. On top of that, what you will do, you will install an operating system, an OS, which in your case might be Windows, or you might be even using Mac as I'm using, or you even might be using Linux purely. Okay. Even Mac is a Linux, but let's say you are using Linux player purely. And on top of that, if you want to if you want to install another OS, then it is possible. But if you want to create you want another OS running simultaneously parallelly on top of hardware, then it's not possible. Okay. Now why it's not possible? It's because of the reason that kernel cannot allow this, or actually in between this hardware level, like hardware and OS, there's also a slight software, actually a program running, which is called kernel. It acts like an interface for the users, or let's say for the OS. And on top of OS, the users are there, right? We interact with OS, and OS communicates to kernel and the hardware, right? So this kernel doesn't allow the split up of hardware into two, okay, or in any other part or any other format. So that's the case when you have an OS. On top of OS, you can create you can install another OS which actually works as a different PC in itself, which is called virtual machines. And the software that helps to do is are called hypervisors. Hypervisors. So there are different kind of hypervisors. So let's say virtual, if you are using VirtualBox, so VirtualBox internally uses hypervisor. Then VMware also uses. There's EXFI. Then there are many more to use. Okay. So this is how the complete stack is built. So let me again uh, do this. So first there's hardware, where you have all your RAM and CPU, everything. On top of hardware, you have your OS. On top of OS, you have your hypervisors working, and on top of hypervisors, you can have n number of virtual machines. Okay, actually, this n can be also restricted by the resources you have, because let's say you only have a 8 GB RAM, so you cannot create more than 8 systems with 1 GB RAM. If you do so, then your main system, your main OS would won't be operating smoothly. You will feel a lag in your system. So this is what a VM actually helps. And as I told you, the problems why we need containers, why we need virtual machines, the same problems. We need an environment, we need isolation, we need something where we can have multiple uh, different things running apart from disturbing our main host system. But the problem of VM was it was too slow to set up. So this particular this problem is solved by containers. So if my virtual machine is up, uh, yeah. So let me show you what's the power of Docker, and how it's been operating or working. So as I told you, this is the VM. Let's say the Mac OS was my base system, right? On Mac OS, I have my Fedora, which is a VM using UTM. Now UTM is my hypervisor. So this is a terminal or a shell of a system. If you have MacBooks, then even you have a terminal on it. Okay. So on this terminal, if you I already have installed Docker, but I'll show in today's lecture, or in next lecture, if time's there, I'll show you today itself. So yeah, and one more thing, don't think that right now it's 3:13 on my system, so I'm not in India, or this is not a live session. Actually, I am in a different country right now. That's why the time delay is there. Otherwise, this whole session is live. Okay, so I because I can see all the comments. Last comment was by Shubham Sen, Raja Babu. Good evening to you all. Good evening. So it's not an recorded session and played or streamed on YouTube. It's live. Yeah. So let's move to the practical. So as I mentioned, that Docker is a tool or a technology for virtualization. So if I run a command Docker run it, and let's say I want to use CentOS. Many students might be enrolled in that um, lectures, right? And even if you want to still, actually, I don't know if, I guess the registrations are stopped, but you still want to learn about Linux, so you can still go to the YouTube page of Right Education, and there a whole playlist would be there. Even you can find that in the comments in the in the description. Yeah. So this is a small command. This is a very small command of only 4 words, if we say. And when I press enter, so this is a different OS. This is I am into a CentOS right now, and this is a shell of a completely different OS. And how much what fraction of second it took? I guess it was even less than a second, right? So this is the power of Docker technology, and let me prove you by the host name. Like if you know that each system should have a different host name. No two systems can have the same host name. And if I open another terminal, and if I type host name, So it's Fedora, and here the host name is B02 or whatsoever it is. So now you got the power of Docker and how much fast it is. Will in this series you will come to, okay, wait. I guess someone wrote, I just saw that you need to increase the font. Yeah, I guess now it's visible. Yeah, so yeah, you can see that this was the just four word command or four letter command, not letter, sorry, four word, and a whole new system is in front of you. And this system is completely different from your base system. Now, how? If you want more proof, I once showed that it's the by the host name, and now I'll let me see if I do ls. So it's a completely different file system in here than what we are having right now, okay, in my base system. So this is what a container technology does, and one of the tool of container technology is Docker. There are many more, and our syntax after that almost remains same. Like there are some few differences, but almost remains the same. Okay, so like just to the uh, explain a short explanation of what this command did. So in here you can see it is there are four things I wrote. So in Linux, this is purely about Linux. So in Linux system, what are there? There are commands. There are so many different commands. So here Docker is actually a command, and run is it's for is we can say it a flag, a parameter, or whatsoever you want to call, but you can say um, an argument also. So Docker run. Now here I wrote hyphen it. So in here, what does I means? So I means for interactive and terminal. I want an interactive terminal on which OS? CentOS. Now, where does this CentOS comes from? Actually, in Docker world or in container world, it is called image. Okay. In VM, if you want to in virtualization, if you want to create an VM, you need an disk file, right? An ISO file. So similarly, in Docker, you need an image, and to download image, you there are many online repositories from where you can download images. But Docker has its own repository where even you can also put your own image. Okay, and we will see how to do this. So if you don't have this image in your system, then this command, when you run this command, it will directly download, or by default first download this image and then give you this shell. Okay, this is called a shell. What you are seeing right now, right? You can run commands in here. This is called a shell. Yeah, so let me move back to the system. Right now, don't focus, like you might not be able to do the practical side by side because of the system issues, or not issues, but you don't have VM setup. But let's say once you have, just make notes of these commands. First command, as I showed you. Now I'll show you how you can check how many images your system has. So you can run docker images command, and you can see I have three images. One is Ubuntu, one is CentOS, and one is of TensorFlow. Okay, so TensorFlow is nothing but it has all the deep learning and machine learning libraries pre-installed, and Python also. So this made your work so simple, right? This is the use case I was talking about. Environment, the third problem. If you try to manually install TensorFlow and set the environment, it take too much of time. And sometimes if you have libraries clashing, so that's another headache, right? But the TensorFlow guys has provided this image, and I have downloaded it. How you can download? You can download by Docker. If you know the name, you just need to do Docker pull and the name of the OS. Okay, so let's say I have already pulled the CentOS and Ubuntu images, but if you want to pull a different OS, you can name it here. And how you can get the name, by going to this site which is called Docker Hub. So in here you have all the different images. As I told you, for virtualization we need ISO files, but for Docker we need containers. Sorry, for we need images, and from images we build containers. So you can see there's one for Couchbase, Ubuntu, PostgreSQL, MySQL, even Python, OpenJDK, uh, BusyBox. So there are so many of that, and you can even browse it here. Just say, let's say CentOS was there. So CentOS is there, and there are so many other flavors or other companies which have posted their own flavor of it, right? With some more settings, and might be different softwares in it. So you can even see the command here, docker pull CentOS. So by default it will pull the latest version that they have, right? Because CentOS there are so many versions, as you can see here, and that's called tags. The version name are called tags. So let me show you. If you want to pull an image of CentOS version 7, right now I am having the tag or the version which is latest version, but I want for 7, so you can mention using colon. If you hit enter, it would contact to Docker up first. And why I told first, because even you can set which repository it should first ping to, or first see to. So it would first go to the Docker up, look there. He found that there's an CentOS 7 image there, so it would download it. Now let's wait for it, and you will see that there's one more image been set up, will come up here, and you can use the same as I already shown you, right, by the docker run it command. And what does that it mean there? We'll also see more commands like this to even solve more use cases. Yeah, so it's completed. Now if you do docker images, you can see that now there's one more CentOS, but now the tag or the version is 7. And you can even launch it, docker run it CentOS and colon 7 to mention the version or the tag number. If you hit enter, again you are into the OS, and it just launched within a second. You don't need any extra time, right? Yeah, so this was a brief, very brief practical or very brief introduction to what Docker containers are, and how they perform, and how they outperform VMs. You use like it only took 1 second, right? Even less than a second, if to mention it. So now let's move to the topic of installing Docker. So to install Docker, there are two steps you can follow. So if you know about Red Hat or flavors of Red Hat, as I told you earlier, Fedora is a flavor of Red Hat. Okay. So the setting yum here would be same. Okay, you need to follow the same steps wherever you are using yum in any Linux distribution. But in Ubuntu you have apt-get, right, to install install software. So let's follow that steps to set up the yum repository. So in CentOS, Fedora, Red Hat, you would get your yum repositories in etc yum repos.d. And here you would have you might have different repos. Right now I am having all kind of different repos for Fedora. In Red Hat you might have different, but there is a repo called dockerc.repo that we need to create. Okay, so vm is a command to edit any file, any text file. So if you go inside it, there's lot of information why, like how this came. So if you and one more thing, if you are familiar with setting up of yum, then it's fine to follow the second method which I'll tell. But if you are not, then right now I am showing you the method. Okay, so let's begin with, sorry. In the Google you can directly type install Docker, and let's say you want to do it on like Fedora or CentOS, then you just need to do type that, and the first page which appears, you go into it, and they will tell you steps to follow, different steps to follow, and follow that steps. And if you are still not able to download the software after following the steps, you will reach to this final step. And no, sorry, not this one, just a minute. Yeah, this one. So after following this step, you will have your Docker container. Do everything which is told until here. Okay, don't uh, um, okay, let me do one thing. I'll try. We have time left, so I'll first remove yum. Okay, and I guess I for me for but for me only, I need to run this command. Otherwise, you don't need to run the command which I'm running right now. Docker remove. Sorry, yum remove. Okay, you don't need to do it. And Docker C I already uninstalled. Right now I am uninstalling everything so that I can show you how to install from scratch. And I'll also remove the repository. Now I don't have the repository, and even I don't have Docker command. Okay, Docker command not found. And CentOS, they will tell you this part, but I guess in Red Hat they might not tell you. As I told you, there's one other flavor of Docker is called Podman Docker, but we don't need that right now. We'll focus on Docker itself. So in this page, come again to this page, and let's begin by you don't need to even do this. This will remove the Docker files and completely uninstall Docker from your system. So come directly to this and start running the commands as shown. So first it would download some yum utilities. You don't need this yum utilities, but just do it because they are telling, like if they are asking you to, but you don't need this yum utils. Then you need to yeah, this is the main command which will download the repository, and you don't need to create your own repository. Okay, for the people who don't know how to set up repos. For people who know how to set repos, I'll also show a different way. But right now, let me just be cautious. I'm not using CentOS, I'm using Fedora. So go to Fedora, and you install the particular one. Okay, it will take some time. Okay, until that time, I'll show the way to set up your own yum. Right now, I'm not in the desired directory, but what you need to do, you need to go to etc yum.repos.d, and here you need to create a file. Okay, right now I'm not creating in that, but you need to create it here, and then you just do vm docker.repo. You can give any name before the dot, but the extension should be repo, otherwise it won't work. Okay, so after doing this, you need to first give the name, general name, let's say docker. Then you need to give the name, you need to give whether you need to enable it or not. So enable is equal to 1, and finally we'll need a jpg, we'll need the base url, the location from where you are installing softwares, right? Mm, as soon as this comes up, I'll show you what how the content of yum are, the repositories are. Or let me go to uh, and cat, let's say fedora dot repo. So you can see, first of all, you need to give the name of the repository you want, or even you can mention it here, name and the name you want. Then you need to give base url. So this is the location from where you are downloading the softwares. Okay, it can be from your local system, or the from the system itself. It can be from the internet, or it can be from a different server also, ftp server or whatsoever you want. It is commented here, commented it out, but we need to like for our case we need to uncomment it. Okay, so let's go and edit it. vm docker.repo. We need base url is equal to, now what we need to put here I'll tell you. Then we need to do gpg check is equal to 0. Now what is gpg check? Just now understand that whenever you install some softwares, it check for the security purpose whether you are been, you are in a man in a middle attack or not. So if you do jpg check 0, so it won't check, and it will tell yum that you are trusting the source to download any softwares. And you don't need to put jpg check is equal to 1, otherwise you need to write more code here specifying from where you need to verify the information. So don't do that right now, and go to the web, google, and just do index of docker. Yeah, index of docker, and the first site, not the index of docker ce. Yeah, do index of docker ce, click on this link, and in this link go back. This is dot slash means go back the parent directory. Again go back, again go back, and okay, after from this, if you have an R64, go to that, check this from your, if you have windows, go to my, if you have windows, then you definitely have to do x, like this x86 64. Otherwise check if you are linux based systems, go to this particular folder and do what am I doing right now, and click on stable, and you need to copy this location, and you need to put that location in here in the base url. Okay, and yeah, if you are following this second step for any flavor, if it would be red hat, CentOS or fedora, the link should be this. Okay, it should be CentOS here, and it should be for 7 and not 8. even though if you are using latest, because there's some problem with it. Otherwise, if you are using this first method, do as it is told in the okay, wait, in this document itself, it would work fine. I showed you like my Docker command was working very fine, right? Actually, it's taking a lot of time. Let it. I'll let it be completed, and then we'll follow the steps in this document. So, how much time is left? Okay, we still have some time. Okay, so mm, I'll just take a minute pause. Okay. Yeah, let me even take the comments, the questions you have. Um, how can we Neetu Bhardwaj is saying, how can we set the password and username to containers? Yes, yes, actually you can set the password and username, but what will happen is whensoever you are creating the container, that I told you I run a command, right? Docker run hyphen it CentOS. So at that time it won't ask for password. Okay, so for if you want to set up if you want to have a setup while someone is running the container and it asks for password, then you need to adapt a different approach. You cannot completely do with the help of Docker. But let's say once you have started the container, let's say you set a password for it, you created an image out of it, and then you launched an container of it. Okay, so then that password and username would be valid. Let's say if you are having a service which needs an username and password, then you can use the set username and password, but while launching it won't ask. So if your question is, if you want an username and password while launching the container, then that's kind of not possible purely with Docker. You need to integrate it with something other script like Python or shell script to do it. Otherwise, you can set username and password, but it would be used only for the services if you have any. Okay. Do we need VM to use Docker? No, no. Prachi, actually, you can directly use it on. I guess if you have Windows, then there's on. If you go to Docker main page. Oh, sorry. If you go to the Docker page, and if you see there's a thing called desktop, so you can download a Docker desktop for it. Okay, I guess it was in the main page. Docker desktop for Windows is also there, for Mac it's also there. Okay, so you can use this if you have Dockers, and if you have Windows and directly want to use on top of Windows. But I would suggest that you using Docker is also beneficial if if you are using it on top of Linux and not on Windows, because you will definitely need you will be definitely working on a Linux environment and not on a Windows environment in industry. Anand Sharma, you need to follow the same steps for Red Hat 8.4 also. I guess if you follow the website one, this one, the what they are telling in RHEL, just try by doing RHEL this one. But if it don't work, or if it's not downloading, then you need to set up your own yum, as I showed you as the second measure, right? This one, create this repo. The repo which I am showing you right now, create a repo like this. Okay. Uh, then installing Docker on Windows, does there need any other software for setup? No, as Prachi, I showed you the way, right? You go to this website, the Docker's main website, and download this Docker desktop. Uh, Neetu is asking after launching. Okay, so your question was how can we set up the password and username to container after launching? After launching, you can definitely set as that's what I told you. See, again I'll give okay. I'll okay. First, let's the installation is finished. Let me install Docker first. Then only I can show you practical now. The next step was okay. Wait, I need to switch to Fedora and use this to directly download the repository. And don't be confused about DNF. Actually, DNF and yum are siblings. They are almost same. So uh, don't worry about DNF. You can also use yum instead of DNF. Okay. Yeah, so after running this, you will see that the same Docker repo came, and if you go inside it, let me. You will see the same kind of look and feel which we manually created it. Just I told you keep it as 0, otherwise you need to add this, but it's better not to. You just give 0 because it's a trusted source. Enabled is 1, base URL is given. If you wish, you can give name, otherwise you cannot, as you would have already given it here. But otherwise you can give the name also. And finally, you can run dnf install docker c. Okay, yeah, just do it. Or otherwise you can directly run the command docker install docker c. Wait, let me even show you. If you do sudo yum repo list, you will see that you are successfully, if you see your repo id here or repo name, then you have successfully created the repository. As I can see you, docker c stable has been created. So now you can run that. Okay, sorry, run this command and it will install docker for you. Prachi, for Windows, which virtual machine is good to use? Which virtual machine? Yeah, you can definitely use CentOS or Red Hat. Yeah, you can get both of them free online if you search for it. I'll tell the team to do it. And let's say if you don't have access to Red Hat or CentOS, then you can even use Ubuntu. They have their websites open and they are freely available. Let me just show you CentOS and yeah. For if you want an Red Hat image, then you need to create a free account on their portal. Okay, you need to create an account, then you can get a free image of Red Hat, latest Red Hat. So let me show you if I have it. Red Hat 8.4. Yes, this was the link. Actually, you need to go to this site and uh, create an account, log into it, and then if you download it, yeah, they will give you the latest version. As I can see, latest is 8.5. Okay, very nice. 8.5 is now live. It's launched recently, so you can download it from here, but you can see it's very big, 10 GB. So you can definitely use Red Hat. Like I cannot say that this is very famous VM, or this is very famous, because each VM has its own speciality to perform. It's not like that one VM is better than another one, because in industry widely Linux is used, and it can be any flavor of Linux, but enterprise like Red Hat is been maximally used. Even Ubuntu is the uh, favorite for developers, so you can even say Ubuntu. And flavors of Red Hat, which are CentOS and Fedora. Actually, CentOS and Fedora, as I told you, it depend on the use case. Red Hat are more used for deployment purposes. Okay, as they are used more as servers rather than developing machines. Okay, you can use Ubuntu and systems like that to develop. You can still use Red Hat to develop, but Red Hat VMs in industry are widely used for deployment and that sort of purpose. And for development, actually this is the developers favorite. If I say you, if I put it in this way, Ubuntu is developers favorite. But I would say, if you are getting hold of Red Hat, as I showed you, you can definitely go for Red Hat or its flavor, which are CentOS or Fedora. Yeah, one more thing, if you have M1 Max, you won't be able to set Red Hat or even CentOS. Okay, this I have described this problem in my video on my channel, so you can go and have a look why we cannot and what's the best alternative. I found Fedora to be the best, because it's they are all siblings. They are the the same project. They are downstream projects and upstream projects. Actually, Red Hat is here. Red Hat is in between. Fedora is the upward project of Red Hat, and CentOS is the downward project of Red Hat. Okay, so this is how the Red Hat has managed the hierarchy. Yeah, but actually Red Hat is widely used. As I told you, they are upstream and downstream project. What happens in downstream projects is the new softwares comes directly into this. They are tested, everything is done, and then this they are launched to Red Hat. And whereas the future coming, like let's say they're still to come, are here, and many developing are also here. There are few bifurcate, like there are some differences, but it's very minimal to understand. And but Red Hat is the recommended one. Okay, so yeah, now as we have installed the Docker successfully, either way, either you can follow this documented way or go create a repo like this. If this document way doesn't work, because I got many queries from other people also, from my other training and internship program, that following these steps is not helping to install Docker, then you follow this manual step. And then you need to start Docker, because Docker is a service. It's actually a server client model. Okay, we'll come to that. So just a minute. Yeah, so now you need to do system ctl start Docker. Okay, just what happened, system ctl status Docker. Okay. Yeah, it came up actually. Let me just do system ctl start. Okay, that's not an issue. System ctl enable docker. I guess it would be only, a warning. Yeah. Now let me check. Okay, that's I wait. Okay, wait. Uh, if this still creates an issue, then we need to install Docker using the second way. Yeah, now it's working fine. Okay, so sudo docker run it CentOS. Yeah, now it's working well and good. But if you face any issues and you are not able to run the following commands, then do follow this second step. As I told you, there are some issues with the repository they gave to us by while downloading it. So you can always depend on this. This is a universal solution. Okay, if I say so. Yeah. So now I guess there's only few minutes left. Uh, so I'll take the doubt session, and after that we'll end this first session. In the next session, we'll take the point which is server client. If briefly explaining what is server client model. So if you see like why I ran systemctl command is because I told you that Docker, we need to start the Docker services. Okay, now by services I mean that there's two part of it. One is the server part, and one would be the client part. Okay, so usually on the internet, what would happen is servers would be running somewhere, on the and like in the data centers or AWS services, which you might learn in future if you don't have. Just stay tuned with Right Education. So what would happen? You have servers here, and we on the internet are the clients. And what would happen, we would connect to the servers and get the information back. Any kind of service we are using right now are the server client model. Now how? So let's say if you are using Google Drive, right? Google Drive, so it's actually a server, and it's running this service, and you are getting or you are using this service via a web app or a web browser. So this is called a server client model. Okay, so Docker also works on a similar concept where there's a server program. It's everything in Linux. There's one interesting thing. If you have not thought in this way, in Linux or in any OS, in Linux or in any OS, you can only interact with two things. What are they? They are files and folders. Nothing else you can interact with. At the end, everything is files. Okay, even folder is in turn actually a file internally by its mechanism, but we still consider it different. But everything at the end is files, what a user can access or can access to, right? Even codes are also a file, and even executable programs are also a file, right? So this server, now by server I mean the server program is running and there's a client program running. Okay, so in Docker term it is called Docker daemon, which is working, and there's a Docker client. Okay, which is a Docker command. Right now we use Docker command, right? This Docker. So we can say we are client and we are communicating to server with this information, and server is getting us this shell back. But in this case, this we are not on the internet and server is not on AWS or anywhere else. This both the thing is tightly coupled into a single system, which is our this VM. We have both running in this single system. Okay, but in next classes we'll see that how you can use this server client model. This is a very simple diagram, right? This is a server, this is a client. Now server programs have services, different services that can be used by us. But no, this is not that simple. This is very huge. Okay, this concept is very huge, and how this will help you or how this impacts you will know in the next sessions. Okay, so now that's all for the for this session, and now I'll take the Q&A. Okay. Yeah, Prachi, yes, you can use VirtualBox. I guess VirtualBox is very simple to use. Use VirtualBox. Are there any other questions? You can type it in the chat, in the live chat, and I'll try to answer them. Today's session was just an introduction session. Even it's not planned on Sundays, as everyone would get only single day to enjoy. But from now onwards, we would have it the sessions from Thursday, like on Thursday and Friday, not on Sundays. Yeah, thank you, Hari and Rahul. Okay, then let's meet on the next session, which would be on Thursday. Until then, bye bye and take care.